There are times that we may need to reinforce a region of the stack, and the vertical stiffeners are one way to achieve that objective. To access, go to Geometry and then select Stiffeners and then Vertical. Clicking Define Stiffener will let you select and modify which stiffeners you will use. You can select from Flat Bar, Structural Shape, and Custom. When making your selection and entering your data, you will see a graphical representation of the stiffener on the right. For this example, we will specify a flat bar stiffener. Now we enter the thickness of the bar, which is the dimension that is tangent to the cylindrical shell surface. The depth is the dimension that is perpendicular to the surface of the cylinder. The graphic at the right indicates if you have entered it as you intended. Select the material for the stiffener. The temperature is used to determine the material properties. It does not perform any type of differential thermal expansion analysis. A corrosion allowance can be specified, and it will be applied to all exposed surfaces, and so the flat bar thickness will effectively be reduced by 2 times the corrosion allowance. Finally, you can check the inside box if the stiffener is actually inside the stack rather than outside. Once finished, click Save to return to the previous menu. Top elevation is the top of your stiffener and bottom elevation is the bottom of the stiffener. A cylinder is a favorable aerodynamic shape, but when we add vertical stiffeners, it becomes less aerodynamic. We account for this by specifying the shape factor. Depending upon the code being followed, a bare cylinder might have a shape factor of about 0.7, but when adding vertical stiffeners, this would typically increase to about 1.4. This higher wind drag will only apply to the region with the vertical stiffeners. Asymmetric means the stiffeners are not evenly spaced around the circumference of the structure. If unchecked, the stiffeners are evenly spaced around the circumference. When checked, the user will then manually specify the orientations for the stiffeners by clicking that field. You can enter one or more stiffeners at any orientation that you desire. Quantity is how many stiffeners are currently present. If the stiffeners are symmetrical, then you manually specify this field, and if they are not symmetrical, then the field is automatically determined based upon the number of orientations that you specify. The first orientation indicates the orientation for the first stiffener. If the stiffeners are symmetrical, then you enter this directly, otherwise it is determined automatically based upon the orientations that were entered. Click Save and see your work, and the stiffeners will be represented graphically on the stack. There is also a vertical stiffener option on the breech input windows. It is important to know that stiffeners added to the vertical stiffener screen here are only going to be considered in the combined section properties of the cylinder with stiffeners. No check of the stiffener itself will be performed. If a vertical stiffener is specified in the breech entry, then if one of the Troitsky methods are used, the stiffener is going to undergo different checks to ensure that it meets those requirements.